Here's this graphing tool. The graphing tool I've got on the screen here is the show bags question. If you've done the Gawler show bag question, all right. What I've done here is I've typed in my objective function, which is 6x plus 5y. We've got our constraints. X is greater than 0, greater than or equal to 0. Y is greater than or equal to 0. And 2x plus 3y is less than or equal to 36. Have I done that right? If I've done it. You can see here, this is showing us the feasible region. It's also showing us sort of like where the points are. See all those white dots? They're all the feasible solutions. Okay. Now watch this and watch it carefully. We're watching. When I type in my objective function, we can actually solve it electronically. And watch what happens here when we click solve. In comes this little red line. And what this red line is showing is where the optimal solution is. So the optimal solution clearly occurs at that vertex there at 18, 0. So if you've done the Gawler show question, the optimal solution was selling 18, what were they called? Show bag A's, were they? Is that right? Did I do it right? Oh, they were called super show bags, were they? Yeah. Is there a third line? Oh, what did I miss? See, this is good with that. Oh, X is less than 8. Oh, there we go. The ones that we missed there. Let's add them in. And it was Y was less than or equal to 10. Sorry about that. Here we go, we'll graph it again. It's just being a bit slow here. Good. The good thing about solving it electronically is I can then just plug it in. There's our better feasible solution. Let's hit solve and let's see where that little red line comes in. Watch for it. Bam. It's there. 15, 2. So 15 super show bags and 2 maxi show bags was the optimal solution. Have a look at this. Optimum, and you made $100 from it. Later in the question, something changed. Later in the question, the prices changed, didn't they? The very last question. Let's have a look at this together. So the graph still stays the same. The only thing that changed was this objective function. The objective function changed from 6x plus 5y, and it changed to 4x plus 6y. Now watch this. Let's solve it now. Because I'm a visual learner, so I find like seeing this visually here really helps me understand it. Try pressing solve again. In comes that red line, showing us the optimal solution. There we go. Now, you would have noticed when you did your table, because you know how you have to like set up the table again? That point there and that point there were 2 maximums. So the optimal solution occurred at 2 points, which was 15, 2 and also 3 and 10. Here's an important understanding that you need to take away, and this is new. If there's 2 maximums, all of the points that lie on that line are also optimal solutions. So here, everything that lies, all of the solutions on that line are optimal. So you have to actually check if there's more optimal solutions. In these contexts though, the context that you've been looking at so far, we don't care about all of the solutions because, well, you can't sell half a show bag. You can't sell a quarter of a show bag. So can you see by the dots on the screen that the ones that are the blue dots are the integer results? So you have to look on your graph as to where are the whole number combinations that also work. All right. And sometimes there might actually be infinite number of solutions. You know, if it was like mixing two chemicals together, you know, how many of chemical A do you need and how much of chemical B do you need? Well, you know, you could put 2.3 milliliters of chemical A in, couldn't you? And 6.8, you know, like in that context, the decimals count. But in the context where it's like show bags, number of elephants, number of people, okay, you can't have half a person. So notice that you need to explore what are the options along the line. Max, sum up what this learning was in this last 5 minutes. Using technology can help us. Yeah. But can you summarize for me what was the important new bit of learning for today before you pack up, please? So like, and how can you tell that from your table? How can you tell on the table that there might be lots of solutions? Tell Max, John, if there are two optimal solutions, yes. So if there's two optimal solutions.